Hi everyone, welcome back. This is the third of my videos on this playlist. Please remember I have hundreds of maths videos, over 400 maths videos. There are playlists. There's playlists on every topic you can think of, from fractions and decimals, percentages, right through to 3D vectors and calculus. Everything's there. So if you need help, a lot of people are asking if I'd make more videos on topics. I have videos on most topics. Trigonometry, area, volume, lots of them. Now, I keep making more. I've got hundreds in mind. This is because someone asked me yesterday if I can make some videos on it. Now, I'm trying to meet some of their needs for their exam. We've gone through concepts. So the first two were the basics. This goes now a step further. So we're talking about the area under the curve, and next to that red one we have there. Interesting word usage when we say area under a curve. So that's actually above the curve and that's below the curve. So do I mean area under the curve? We're talking about vertically between the graph and the x-axis. Vertically between the graph and the x-axis. The interesting part, I'm going to preempt because of time, I don't want to make the video too long. That's going to be a negative area. So if I do the integral for that, I'm going to get a negative area, and that one will be a positive area. And watch out for the traps. In Australia, they love putting questions in to see if students realise that's a positive area and that will come up as a negative area when we do the integral. So let's have a look what happened. If we didn't know the graph, if you don't know your graphs, I've got lots of graphic videos if you want to watch them, heaps of them, especially on parabolas. So you need to know where the graph crosses the x-axis. Oh, there's so many shortcuts and things I can tell you, but this is an introduction to the topic, so we're not going to go there at the moment. I want the understanding that you need an integral from from 0 to 1, so that's what's a trap. Integral from 0 to 1. So we're starting an x value of 0 and we're going to an x value of 1. Then we're going to add to it the integral from 1 to 2. Now there's one thing you can do with it, is to make up for the fact this is negative, this is underneath the x-axis. You can put an absolute value around the whole thing, and we're going to do that. There are shortcuts you can do, but we're not doing them now. Or they're not really shortcuts, but more understanding that can shortcut the process. So we've got an integral from 0 to 1 of that graph. We're talking about the graph of x squared minus 1. Now, if you don't understand this, dx is talking about little bits of x, and we get a whole lot of them, whole lot of little rectangles in there. We change it into dx. And basically, a lot of people don't realise that there's the beginning and there's the end, so there's actually a bracket around that. And some people will write the bracket in, I don't, because it's obvious from the context. That's the beginning and that's the end. Then I'm going to get the area of x squared minus 1. But this time, instead of 0 to 1, I'm going to go 0 to 2. Now, I'm going to be a little bit painful, and I'm going to go through both of those and work out what they are. So what happens with an integration? So I'm going to write the absolute value in, but I could have just put that in later. Or maybe I should do that now. I'm going to leave it out and show you how it becomes a negative area. Let's have a look what happens there. So if I integrate it, what do I do with integrate? I talk about the i's of these students in the last test, my year 12. So I've got, this is for, by the way, the last year of high school in Western Australia and a lot of states. You do start on some of it last year in year 11. So it's the last year of high school. Now that will apply no matter where you are. Any country just about. And some countries go to year 13. So this will be the year 12 and 13 years. Now a lot of it comes back at university as well. So you increase the power, so that's an x cubed, and you divide by the power. Minus 1 becomes an x. You can watch it on previous videos. It's actually because there's an x to the 0 becomes an x to the 1. Now I can put plus a constant, but I don't have to put plus a constant if I'm substituting values, because the constants will eliminate each other. Then I've got another integral. So when we're substituting values, a lot of people will write them here. Some people will write them at the front. You can write them basically wherever you want. So now we're going to have another x cubed on 3 minus another x, and this time we're going to substitute 1 to 2. So now we're talking about substitution. So we're going to substitute what numbers? We're going to substitute 1 and we're going to substitute 0 and we subtract them. So let's have a look at it. So I'm going to put a bracket for it. So that's a 1 cubed on 3. So 1 cubed is 1. Watch out, lots of people do silly things. And then we subtract the 1. And you can see that we're subtracting more than we had, which is going to give us a negative answer over here. Then for the rest of this first bracket, we could write big brackets around the whole thing. Maybe I should, so it makes it clearer. Some people are confused with more brackets. Put in 0, so that's 0 cubed on 3, so that's 0, and that's minus 0. So how much effect did that 0 have? Nothing. Go to the next part. What have I got? Substitute 2. So we're going to have 2 cubed, which is 8 on 3. Oops. 8 on 3 minus, substitute the 2 is 2. Then we're going to subtract, substitute what? Substituting 1. This is looking like it's getting along. That's 1 cubed, which is 1 on 3 minus 1. And you see all those crazy calculations. You've got to be really careful you don't just mess them up. My black pen's running out. I'm going to go to this one here. So let's have a look. I'm going to get rid of the big brackets. Don't need them anymore. 1/3 minus 1 is minus 2/3. And that's minus 0. So there's the first calculation. And you can see that's a negative area. This is why I'm going to go back here. Now you're seeing the negative. And say anything that's below the x-axis is going to be a negative. Anything that's above the x-axis is going to be a positive. Maybe I should use a different colour pen. So negative for below the axis, positive for above the x-axis. Now for getting the area, we want to take that into account. So we're going to want an absolute value there. So in other words, the answer to this section, we want to ignore the negative. So then I'd have an absolute value there. I could put in at the end. Then I've got an absolute value there. It's looking a bit crazy. That's what I'd rather just take into account. And an absolute value there. So for the last bit of it, now I have 8/3, so that's 2 2/3 minus 2. Now I've got minus, I could do them all in one go, I'm doing them separate. Minus 1/3 plus 1, and we've got to add up those numbers and see what we get. So here's the big part. The absolute value gets rid of that minus 2/3 to turn it into 2/3. Now over here, I've got 2 2/3 take 2, so that's plus another 2/3. And I'm going to do it this way. Watch what you can do with this. 1 minus a third. So that's actually plus another 2/3. So the total area that we've got to that question is really amazing, because it turns out to be 6 on 3, which is just 2 units. And most schools or most countries will probably expect you to put in the unit squared so you know what's happening. So the area under that curve turns out to be exactly 2. And what I keep talking about, historically a lot of people would have known how to get it, and they could have done it by drawing up boxes and go, oh, that turns out to be 2. So fascinating that a curve can turn out to be exact numbers. So that's probably enough. There's so much more I could do, but I'm running out of time and energy. Thanks for watching. I hope it helps. Bye for now. If you're in the last 2 years of your high school and you're in high level courses, doesn't matter whether you're in South Africa, Canada, India, Indonesia, from what I've seen, Japan, no matter where you are, it's basically the same content. So have a look at this course here. If you're looking for calculus, and I've split it up into various special things of calculus, differentiation. A lot of people have trouble with factorization. A lot of people have trouble with graphing. The one's gone black here. Graphing hyperbolas, cubic, square roots, parabolas. Goes on and on what you can graph there. Index laws, and they get tricky, muck people up a lot. They have a lot of trouble with those ideas. Integration, logarithms. Now if you click here again, you can get a lot more topics, a lot more playlists. I'll do it briefly. And you can come down to the bottom here, and we've got trig equations, surds, non-right trig, simultaneous equations, sequences and series, and on it goes. And in the very highest level one here, this is where people don't realise how much I've got. I'm going to click on there. By the way, I have these little video lists of good videos to watch before our Year 12 exams here in Australia. They're topics I know a lot of students struggle with, or I saw students have struggled with in their practice exams. So here we go. We've got calculus, we've got complex numbers, matrices, permutations, combinations, polynomials, all sorts of proofs, induction. Big one is this graphing. I'm going to make this one here black. Reciprocals of functions, inverses of functions, f of g, composite function. That goes on and on in that topic. Big topics. You could just look at your textbook and go, have I got simple harmonic motion? There's simple harmonic motion. Have I got simultaneous equations with 3 equations? You can see it just by looking at the chapter headings on your textbook. Trig equations, big one, vectors. In year 11 over here we do 2D vectors, and then in year 12 we go to 3D vectors. So there are a lot of videos. There's 19 videos on 3D and 13 videos on 2D. I could make an awful lot more. Another big topic I've only just coming to grips with myself in recent years is the logistic model, and I've made one called the logistic model for dummies, and I've not gone through a lot of the complicated stuff. I just want to make it simple and understandable for most people to do. Well, as usual, I hope it helped. Thanks for watching. Bye for now.